Of course. Do, 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 do. Do, 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 do. Uh-oh. All right. By the way, real quick, before I forget, something came up earlier that was really interesting. That there's a course you guys take, talk about the history of teaching and blah blah, and then the fact about I often talk to my students about the mental health resources that are available, right? The teachers, very often, the people that go into teaching are, unfortunately, some people that consider themselves last. You're giving and giving and giving. I can totally relate to this. And I figured out if I'm having issues that I feel is detracting from my teaching, I talk to my students about it. Not like in detail or whatever. So for example, my calculus class, I'm not giving any specifics about any person, but they didn't do very well on their last test. I actually was really emotional after grading their tests. But they don't see me for a few more days, and I've gone through it, you know what I mean? So they just see me handing stuff back and talking. So I told them, I said, listen, I cried after I graded, because I know some of you guys are working so hard and you're just not getting the grades you want. I want you to know that it affects me, right? And then of course they started crying, you get damn shit. But sometimes it's good to show students that, right? And I always thought when I was younger, when I was teaching, I thought you're supposed to hide that from people. And you're supposed to be the one that's, I'm in control, and look at me and I know stuff. That's so much bullshit, right? It's so much better just to be genuine. And if you discuss something at a level that's appropriate as far as how much information you're going to give, but if you let people know, hey, I'm having a rough time, there's some stuff going on in my life, just to let you know, anytime I've done that, I've had a much better class. If I don't do that, then I feel like I'm pretending to be me, right? And if you try to pretend to be you, that sucks. It sucks. But also, what's really weird is sometimes I have a lecture that I thought was horrific. And the next class I'll say, I'm really sorry about last lecture. I was off and somebody says, I thought the last lecture was great. What are you talking about? So the other side of the coin is you have no idea how what you're saying is coming across to the people on the other side, right? So don't make assumptions about things, because then you'll start what I call the snowball effect. You'll go, oh, that was terrible. Now I'm going to probably, oh man, what do I do now? And I'm going to probably suck again. Oh, no. Stop that shit, right? Really quickly, specific story. Did I ever tell you the story about the girl that sat in the front row and I thought she hated me? No. So yeah, I'll never forget this girl. She sat in the front row, lectured the whole semester. She sat there like this, just watching me. Day of the final, she turns to the final and she says, thank you, Mr. Waller, this is one of the best math classes. And she walked away and I'm like, what? I thought you hated me. Sorry. So anyway, I try to keep that in my head, not to make assumptions. Maybe a lecture was terrible, but I'm not going to assume it was until I have some evidence, right? Okay. You are going to become teachers. And I'm almost certain you're going into it with the right mindset in terms of you want to give. But just like on a plane, when they say put your own oxygen mask on first, if you pass out, you can't do shit for the kids. So you have to keep track of yourself, right? Your own mental health. Here I am. Look, mental health. Here, let me point to my head. Okay, sorry. That just came up. It's interesting because it's something that's taken me forever to learn as a teacher. That you don't have to keep this line, this hard line. You need a line. You do. But it doesn't have to be as guarded as a lot of people make it. You don't want to go too far the other way and just I had a French teacher that would just, first 30 minutes, he was talking to us about his entire life, about his ex-wife doing this, blah, and we're like, is this going to be the test? Je parle français and your wife sucks. No. Right? Okay. Sorry. So what was your question again now that it took forever to talk about other stuff? Who had a question? I'm sorry? Yes. Thank you for being patient. Rectangular. Okay. I always call this like the ice cube approach to keep it in my head. Like, if I want to do 5 times 6. First off, what does that mean directly? Computationally, not visually. What's the most basic mathematical idea behind multiplication? Repeated addition. So what would that be? How many whats do I have? 5 groups of, no, careful. You have 5 groups of 6. Yes, so it'll be 6 plus 6 plus 6 plus 6 plus 6. Yes? Okay. In terms of rectangular array, it'll be 5 by 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So I get 5 by 6. Is that cool? Keep going. Okay. So I call it making the brownies, right? So you gotta actually cut the brownies. And what would a student do when they're first learning this? They'll love making this picture. It'll make complete sense to them because they like to cut construction paper, they like all this shit. So doing that, they can see that as cutting, and you can even talk about it like brownies. You would say, how many brownies are in the pan? What are they gonna do? Before they know anything, what are they gonna do? How many brownies? They're gonna count them, and they're gonna see there's 30, and that's the first step towards understanding 5 times 6 is 30. Yes? You guys kind of with me? So some of you guys drew it but didn't draw the grid. That's not really good enough. If I just do this, we know this is 5 times 6 in terms of area. Area is way too advanced for somebody who's just learning what multiplication means, right? So you have to show that grid. That's what the students would do. And then they could actually count. Okay, maybe. And of course, what would 6 times 5 look like? Yeah, just 6 this way and 5 that way, yeah? Okay. I like it. Yes? Oh, yeah. So if I ask you to do, what, Jeff, 24 divided by 6 using missing factor, you would say 24 equals 6 times what? Yeah, there's missing factor. That is division, but you're letting the student think about their multiplication tables, which they are aware of. When they first get into division, they don't know what this shit that is. But if you put it in terms of multiplication, they just did that. You would have just done a lot of multiplication with it. Then I feel much more comfortable. 6 times 4 is 24. Well, then 24 divided by 6 is 4. Oh, teacher, I get it. Well, maybe not that quick all the time. Do you guys see what I'm saying? This is the idea of building a new idea firmly on an old idea that they've worked with already, right? That's what I try to do in my own college classes. You want to do it for every human. You want to build something new on top of something old that they feel strong in. Yes? So that if you wrote something related to this and then said 4, that you would have gotten full credit for that problem. Okay. Is that good? Sorry. Yes? Yes?
Can I ask a question?
Yeah.
It's on the quiz on B on number 3. I don't know which one it is, but it's,
Oh, the one with about PEMDAS.
I think so. It's the 7 or
Yes. Yeah. So some of you guys said 7 minus 27. I can't remember what the rest of it. Everybody had the same problem, but nobody had the same problem. The biggest mistake there I saw was people were doing division last. Why does that not make sense? What's the phrase for order operation? Well, not the phrase, but the word. What's at the end of PEMDAS? Addition, subtraction. That's what you do last. It's right there. PEMDAS. It's at the ass end of PEMDAS. So, to do a problem like that one, got 11 minus 5 times 2 minus 4 squared divided by what, Jeff? 10 times 3. Okay. Everybody had that problem, but nobody had that problem. One mistake I saw that I didn't see a lot of was somebody squared 2 and squared 4. But that's not how squares work. Real quick, do you guys see what I said? Not a lot of people did that, so this is good. But some people squared the 2 and squared the 4. Do you guys see what is square? What is exponents? What are they based on? What operation? They will work well with multiplication. They will not work well with subtraction because they're not based on subtraction. You guys see what I'm saying? Maybe. So of course, in this problem, it's 11 minus stuff. Okay, so what's the last thing I'm going to do? What's going to be done last? 11 minus, because I identify subtraction is the last thing in PEMDAS, so I'm going to do that last. So what I'm going to have on this side, this 11 minus is just going to keep coming. He's waiting. 11 minus, I don't know. And then what's the I don't know? 5 times I don't know square. Okay, well, let me do that so that I know what I'm squaring, right? And that's what the first thing in PEMDAS is. Do the inside of the parentheses first. Why is it not fair to make it divided by 30? That is not fair. The way I frame this in my head is division is kind of like penalizing a number. In my head, I got a number wants to be big. So division is kind of like, no. So it's not fair to say this is divided by 30. Why? What's the only number that's dividing? So how could you make it divided by 30? That doesn't make any sense. Right? And again, if you ever had a teacher that said multiplication comes before division, I apologize on behalf of my profession. That is so much bullshit, and that person hopefully doesn't teach anymore. That's bad. That is so bad. I really want this to make sense. And all the Facebook things I see sometimes when I go in there, so it makes me sad. But do you guys see the only number that would go on the bottom is 10? So how could the 3 go with it? No, it's not divided by 3, it's times 3. So, what would I do first here? Yeah, 2 minus 4 is? Negative 2. And you have to say, brain, I know 10 times 3 is 30, brain, but that ain't what that says. The 10 is on the bottom, right? What will they do next? Huh? Exponents. What's negative 2 times, what's negative 2 squared? Positive 4, right? I'm going to make a mistake. You ready? I am making a mistake right now. I just made a mistake. What mistake did I make? What was the operation here? What did I make it? That's some magic level shit, right? Chip. You guys see that? These are the most common mistakes that I see. The most common mistake I saw, besides what I said earlier, was people would make this 6, right? And I agree, 11 minus 5 is 6, but this is 11 minus 5 times, I don't know what that shit is yet. I gotta figure out what that is so I know what I'm subtracting from 11, yes? Okay. What comes next? This is the thing I do last. This entire chunk, what's the only operations in it? And you do those as they come, because they're on the same level. You do them as they come. So what's negative 5 times 4? 5 times 4? 20. What's 20 divided by 10? 2. What's 2 times 3? 6. And what's 11 minus 6? Okay. You see that? I see it. It's right there. Surrounding. Does it make sense? So this is a really good example of students want to be done with the problem. They want to be done with the quiz, get this out of here. The faster you go, the quicker you get wrong answers. So you do save time, I guess. But if you just stop and go, okay, write PEMDAS, write it like that. Do not write PEMDAS in one line, because that's where people start doing multiplication before division. That's bullshit. Like, remember, we could call it PEDMASA. P-E-D-M-S-A. That's harder to say, so we just call it PEMDAS. You have to remember, if you're going to teach students this, if you don't see the importance of this, you have to find it. Yes? This is important. This is the most fun. When you learn a new language, this is basically grammar. Yes? The symbols are all the vocabulary. PEMDAS is the grammar. And if you've ever learned another language, you know that very often grammar is one of the weirdest shit to learn about the language. You're like, I get the words, just do you put the adjective before or after in this language? Is it White House or House White? Well, some languages go white. I'm sorry. Okay. Is that all right for that problem? We could do another one if you want, or we could do a different one. It's up to you guys. Remember, today's wide open. We could just focus on something. Yes, and then I'll come back there.
Can we do over exponents like in division and multiplication?
Do you mean like?
So like on the practice test, there's one like 3 to the second piece, or 3 squared times 3 to the third power.
Yeah. Okay, so let's do one like that. If I had 5 cubed times 5 to the 4th. Do you understand, and some of you guys might understand this because you would do this, where 5 to the 12th would come from? Do you see a 3 and a 4 in there? And then what's the operation? And kids are like, I don't know what 3 times 4 is. But let me blow your brains. There is no 3 in that whole thing. I don't see a 3. I don't. And you're like, Jeff, put your glasses on. What's that symbol mean? What's this actually mean? What does that mean? What does it mean? What's a power mean? That's how many 5s. There are 3 5s. There's no 3. What is it really? 5, 5, 5 times 5, 5, 5, 5. Yes? That sounds very much like a phone number you'll hear in the movie. Call me at 5, 5, 5. You guys understand? So the most basic way to explain why this is not 5 to the 12th is you write out what 5 cubed means. That reinforces what exponents mean. So 5 cubed means 5 times 5 times 5. And 5 to the 4th means 5 times 5 times 5 times 5. And then you say, okay, how many 5s do you see? Because what's the job of the exponent? The job of the exponent is to keep track of how many of the base I'm multiplying. So now how many of the base do I have? Freaking 7. So now you can understand. In fact, like I said, some of you guys can understand it because you make this mistake. And it's a very human mistake to make. It's nothing to be ashamed of. Because you see multiplication, you see 3 and 4, and of course 3 times 4 is 12. But do you see now why multiplying like bases leads to addition of powers? It's like saying I got 3 chairs, and there's 4 chairs over there, so of course you got 7 freaking chairs. I got 3 5s multiplying, I got 4 more 5s multiplying, of course I got 7 5s multiplying, right? Maybe? It's you, Jeff? You say? Okay. Is that better? Who knows? You also wanted division.
Yeah.
So one big mistake I see in division is something like, what if I had 11 to the 5th divided by 11 cubed? Did I have something like that already? I can't remember. No. This kind of thing, is that what you mean?
Yeah.
Okay. The biggest mistake I see people make is they just say 11 divided by 11 is 1. And they say the answer is 1. Why does that make no sense? What's actually on the top? There are how many whats? There's 5 11s. And what's on the bottom? So how many cancel? Or you're thinking of how many are left. How many cancel? 3 of them cancel. Yes? In fact, you could show a student this is 11 times 11 times 11 times 11 times 11. And this is 11 times, get out of there, negative symbol. And then times back. Okay. How many 11s cancel? How many are left? So then we make a shortcut. We make a shortcut. That's the same thing we did with the 5s up above. We make a shortcut. Instead of writing all those freaking 11s out, we go 5 up top, 3 on the bottom. We're going to lose 3. So when I divide like bases, I subtract powers. That is actually a shortcut. So if I have 11 to the 80th divided by 11 to the 77th, I don't want to write 80 11s. Thank you. I just want to go, all right, there's going to be 3 left. 77 cancel. There's 3 left. 80 minus 77 is 3. You guys, does that make sense? Sort of? Okay. Yes. 4C on the quiz. Oh shit, you had the other version. Oh yeah. All right. All right, real quick. What's that? 1. Okay, so anything to the 0 power is 1, except 0. But don't. All right. 0 to the 0, we talked about that one. Anything to the 0 power is 1. So real quick, you just told me x to the 0 is 1, correct? So what if I multiply this by 4? What should the answer be? Yes, right? For example. Yes? Yeah. You guys with me? Why does that make sense? Because the student will look at this and they'll go, oh, it's a 0 power. The answer should be 1. No. What's the only thing being raised to a 0 power? X. This is 4 times x to the 0. What's the difference here? What's being raised to a 0 power? 60. So what's anything to the 0 power? So that's 1. Do you see that? No? You could even do this. What's being raised to the 0 power? 6 is being raised to the 0 power, and b is being raised to the 0 power, yes? And what's 6 to the 0 power? What's b to the 0 power? No. Anything to the 0 power is 1. Real quick, watch. If somebody said b to the 0 equals b, what power is understood to be right there? Do you see how if somebody says this is true, they are saying 0 equals 1? Do you see it? So when I say anything to the 0 power is 1, I don't mean the power becomes 1. I mean literally the whole damn thing becomes 1. So this is definitely not true. Go ahead.
So I understand that the 2 power 0 is 1, but the difference has to be 4 and minus 1 after you do it.
So yours was, so everybody had something like this. Yes, everybody had something like this. Yes? Okay. What's anything to the 0 power? 1. Plus 5 times, what's y to the 0 power? So that's 1 plus 5 is 6. Do you see the power of parentheses? Exponents, even though we call them powers, they're very weak. Exponents are really weak. They can only affect the thing they're directly on. Parentheses come in and help them. They say, I got you. I can help you get over here too. So what I'm saying is, there's a classic thing with students that doesn't understand when they put this in the calculator, they get a negative answer. Because what is being squared? What's the only thing being squared here? No. What is the exponent on? The 2. That's it. Exponents can only go as far as what they're actually on. Does it make sense when I say it's on the 2? That negative is not being squared. Now it's being squared. The negative and the 2, the parentheses help the poor little weak ass exponent out. This would be literally negative, right? Times 2 times 2. You can literally do this. What is 2 squared? Put a negative on it. See that? Because the negative is not affected by the square. This one, I'm squaring both the negative and the 2. That's positive. So people will put this in the calculator, come up and show me and say, math boy, are my batteries getting low? And I'm like, no, you just put it in the wrong. Well, my batteries could be getting low, I don't know, but. You guys with me? Yes?
Can you explain one on the test?
Which one?
The first one.
One, okay, yeah. Oh yeah, okay. How did everybody else feel about this one? So I've given you addition. I've just not told you what A, B, and C are, what numbers are, whatever. But I've given you that this is addition, yes? So for example, what does 5C mean then? What does 5 times something mean in terms of addition? 5C is doing what? What does 5C literally mean? What is multiplication? Repeated addition. So 5C literally means 5C's adding, correct? Can anyone tell me what C plus C is? What is C plus C? C. So what's C plus C plus C plus C plus C? Did I do enough C? All right, let me stop for a minute. Let me make sure everybody's with me. Do you all agree to do this problem? I have to do inside the parentheses first, yes? And inside the parentheses, I have to do this first. Yes? So this is this. But any C's make C, any C's make C, any C's make C. Okay. And just to really make sure, does everybody see where I got C plus C is C? See? Okay. Sorry. It's really funny, Joe. I know. So now I know I can replace 5C with C. That's what we just figured out. So rewrite that now. It's sort of like if I said 4 plus 5 times 2, you would go 4 plus 10. You'd replace it with what it is. Let's replace that with what it is. What is B plus C? I'm kind of just simplifying down, right? Have to do inside the parentheses. What's B plus C? B. Does everybody see exactly what they can? B plus C is B. B plus C is B. Yes? And then how do I finish it up? That's B. What's B plus A? Everything comes back to C. It's too bad. B, A, C. No, it's not. Will you see a problem like this on the test? Yes, you will. You will see a problem like this on the test. I'll tell you that right now. I have an answer. Now, would you give this problem to your students? Absolutely. So if you have kids, make sure. Is Grace Robinson really? Okay, I'm gonna go over. No. But so why am I making you guys know this? Why am I asking you guys this? You're gonna be teaching the damn thing. You gotta know more than them, right? So this is what they're going to see when they first look at an addition table. It's gonna look like this to them. Yes? So you have to get down further into the real stuff underneath what's going on. Because otherwise, when you see an addition table, I already know 4 plus 6 is 10, so this is nothing. This just means nothing. That is like, what the shit? I better, okay, wait. Let me stop and slow down. Then you're doing more like what they're going to be doing. And you understand it deeper. Okay. So, yes? Yeah, sure. Okay, let's do this. Okay, let me keep this here so we can reference it, yes? So the problem is B plus 5C plus A, yes? 5C is C plus C plus C plus C plus C. Yes? So when I put a plus sign here, all of the addition stuff carries. This is not some new operation. This is addition. So 5C means repeated addition, yes? And we just figured out that C plus C is, what's C plus C? C plus C, C. So C plus C is C. Yeah. So C plus C is C. So C plus C is C. Okay, good. Now you could truncate all this work. You don't have to show all this, you know what I mean? That's the work I kind of did on the side up here. But that's where it falls in. You're taking 5C, you're expanding it, you're simplifying. Now what's B plus C? Yeah, B. And then what's B plus A? C. Cool. So if I give you addition, and then I give you 5C, well, you know multiplication is repeated addition. So you can break it down like that. You can only use the table if it's asking you A, B, C plus A, B, C, you know. So you have to break 5C down into what it really means. Yeah.
Could you then go over 4?
Oh, 4 is kind of the next other level of this, right? No, it's this. Oh, I thought it was this one. Yeah, this one's neat. I like this one. Of course you would, Jeff. What you could do for yourself if I gave you a problem like this, and you're like, I don't freaking know. Give yourself a little division problem that you know has a remainder. Can you guys all make up your quick little lone division problem that has a remainder? Could you do that? Make up a division problem that you know has a remainder and do it. For example, 4 into 27. Does 4 go into 27 equal? So you know it has a remainder. So what I'm doing for myself in that case is I'm making a concrete example of the weird freaking shit I gave you. So then you can just see, what would your brain do? What would your brain do? Right? So I don't know what you guys are doing. I'm going to do my example. You can do whatever example you got. They all are going to tell us the same thing. So 4 goes into 27. For me, I get 6, remainder 3. What does that mean 27 comes from then? What does the inside come from? 4 times 6 plus 3. So could you rewrite the problem I gave you? Where does C come from? Real quick, is everybody with me? This work means 27 comes from 4 times 6 plus 3. Is everybody cool with that? Especially if I show it to you. Okay. You guys all cool with that? So this is a deeper question about what do the parts actually tell you. It's freaking abstract as shit. What do you mean B goes into C? No, I just didn't tell you what those were. Do the same thing now. Whatever's on the inside is equal to the front dude times the top dude plus the R dude. Yes? That's what we just saw, isn't it? So now, can you rewrite the problem I gave you? Where's C come from? 27 came from 4 times 6 plus 3. C comes from 25 times B. Good. Now, what am I asking you for? I want to know what 25 times B is, yes? How do you get 25 times B by itself? Subtract 22.
So then are you asking us to solve it, or you're asking us to, like,
Rewrite
where
it.
does B? Oh.
I could have said rewrite this in terms of 25 times B. That would have sounded weirder. This does sound weird. Compute 25 times B. The way you accomplish that is to rewrite it. If you rewrite it like this, then you go, oh, 25 times B is C minus 22. What is 6 times 4?
24.
And isn't that 27 minus 3? Right? That's the idea that this is capturing, yes? Now this is a beautiful thing. In algebra, when I used to be able to legally teach algebra at community college in California, which we no longer can do, I would tell my students, if I give you a problem that requires variables and you have no idea what to do, put numbers in. See what your brain does. Do the same shit. Because what are variables? What are they? What are variables? What are they? What are they? What are they? Huh? Placeholders for what? Numbers. Variables are numbers. So how do they have to act? Like every other freaking number. Yes? So that's why it makes sense. If I do an example with actual numbers in it, that's got to act the same way. Because what does C stand for? Some number. What does B? Some number. They have to act the same way. I don't know if you guys are with me or not. So that one, I agree, was one of the trippier problems on here. If nobody asked me about that one, I'm like, oh, everybody just sort of gave up on it. Because that is trippy when you first read it. Yes? You're like, how the shit am I supposed to know what 25 times B is? Does it make any more sense now? If I give you a problem that's got a lot of variables in it, go, What if he had given me numbers? Let me give myself numbers and see what I do. That's a smart thing to do. Yes? Oh yeah. Sorry. So I like this problem because you have to know what the additive identity is. You have to know what the multiplicative identity is. And then you have to know what closed means. Yes? And you're all like, yes, Jeff. What is the additive identifier? What's the additive identity? 0, because 0 is the number I add to something and maintain that other dude's identity. You add 0 to Jeff, you get Jeff. My identity doesn't change. You with me? What's the multiplicative identity? 1, because that's what you multiply by to maintain somebody's identity. So my set has to have at least 0 and 1 in it. Does it need anything else to be closed under multiplication? How do you check for closed? 0 times 0 is? 0 times 1 is? 0 times 1 is? 1 times 1 is? And that's all we can do, right? Do I need anything else then to be closed? Did I have to go out of that set? No, close that shit off, you're done. What's the smallest set? There. 0 and 1, that's closed. If I multiply any two of them, 0, 0, 0, 1, 1, 1, I stay in that set. If I added anything else, that screws the whole thing up, yeah? If I put a 2 in there, 2 times 2 is, oh, now I need a 4. 4 times 4 is 16. 2 times 4, oh, now I need an 8 and 16. Then you're never going to end. 0, 1, done. Now real quick, do you see from a teacher's perspective, do you understand that problem? I'm checking several things. Do you know those two identities? Do you know what closed means? So it's a very deceptively small problem, yes? But I'm able to check quite a few things. So if you write down the wrong number, like you didn't know what the identity was, but then you check for closed correctly, I can give the appropriate partial credit. Does that make sense? Yes? Or if you put 0 and 1, you don't check for, you do 1 plus 1. I'm like, no, it's in multiplication, come on. All right, I'm sorry. Yes? Maybe. Oh yeah, good. All right. This is some of the newer stuff we went over. Wait, did you mean 14 or what?
There's 2.
Oh, there's 2 14s. I'm not good with numbers. I think I added this later, and then I never changed that one. All right, what does that symbol mean right there? Divides. So whatever x, y is, what does 6 do? Goes into it evenly. So for example, give me some numbers x and y could be. See again? 3 and 2. Because then x, y would be 6, and 6 divides 6, yes? So x and y, between the two of them, I really want you to understand what I'm about to say. Do you all agree that between x and y, you need to be able to find a factor of 2 and a factor of 3, yes? So would 4 times 15 work for x and y? Does 4 have a factor of 2? Does 15 have a factor of 3? What's 4 times 15? 60. Does 6 divide it? Yes. I need you to understand. If 6 divides a number, that means 6 must be a factor of that number, correct? If 6 divides x times y, then between the two of them, they have to make a 6. Yes? Can somebody else give me another x and y that would work? Smaller, maybe smaller. Think smaller numbers. Another x and y that would work. What's the most basic one that would work? What's the smallest number 6 divides? 6. So what's another way to make x times y 6? 1 and 6. You with me? Think about that example. In that case, what are you saying x is? For example, what are you saying x is? What are you saying x is? You just told me 6 is 1 times 6. So what are we saying x is? 1. And one more. No. And what are we saying? And what are we saying y is? Do you guys see that? Just like you said, you could make x2 and y3. Together they make a number 6 goes into, yes? Either one of those examples is perfect. Must 6 divide either part by itself? Do you all agree? Do you all agree 2 times 3 is 6? And 6 divides 6. So what this question is really asking is if two numbers multiply to be something another number goes into, must that number divide either piece? If 6 goes into 2 times 3, must 6 go into 2? In fact, does 6 go into 2? No. There you go. Done. All you need is x and y together makes a factor of 6. 2 times 3 makes a factor of 6, yes? Oh, go ahead.
Could we use this work, like, by printing numbers as an explanation, or do you want to?
Hell yeah.
Okay.
Yeah. Okay, me too. If this must this, when you see like must it be this or something like that, then you just have to give one counterexample. If I said, must somebody with a hat on like broccoli? All I have to do is go find one person with a hat on that doesn't like broccoli. You guys see what I'm saying? And then you can say, no. What if everybody else with a hat likes broccoli? It doesn't matter because that one dude don't. So if I say they must, I'm wrong. You guys see that? Yes, sorry.
So like, for the explain part, you just want us to write that down? Not
Yeah,
like-
totally. You could just say, and therefore it doesn't have to go into either one, right? Now if you use 1 and 6, does it work for one of them? 6 goes into 6, but does 6 go into 1? No. So must it be true that 6 goes into one of the two numbers? No. Again, 2 and 3 make 6, but does 6 have to go into one of the two individual numbers that made 6? No. Now you could really easily make a mistake and go, all right, well 6 divides 12 times 6, right? And 6 divides 12 and 6 divides 6. So true, yay! No, get out of here. That's no good. You managed to find one that works. Right? You don't stop with one that works. You kind of think about it more. You got to think, is there a way to break it? Can I break this? When you see must, that means it always works. So all you have to do is find one place it doesn't work. You're done. Maybe. And again, 14 is a little bit trickier. The division thing is a little bit weirder. I agree. The divisor thing, it's definitely different. You don't see that all the time. Yeah.
Really quick, would it be accurate if we wrote it like the divisible line, like if we put a slash through it?
Oh, sure. Yeah. So these are me investigating. So I can even say, does blah? No, 6 does not divide 2. 6 does not divide 3. Yeah. Yeah, so these, when I wrote these, is just me investigating them.
Yeah.
And then you could just say, no. Yes.
Remember the other 14? To show you that it's divisible by 6, can you just say, like, oh, it goes into whole numbers? Like 2 or 1 in your case. So, like, it's even. We would just say, okay,
It's even
start with
and?
the first 2 digits being even, and then if you add all the digits, and if it's a multiple.
Yes, so if it meets the rule for 2 and it meets the rule for 3, now be even more specific. Why does that mean it's divisible by 6? Because 2 and 3 are 2 and 3 are relatively prime. Yes. If 2 goes into something and 4 goes into something, does that mean 8 goes into it? No. 2 goes into 12, 4 goes into 12, 8 does not go into 12, because 2 and 4 are not relatively prime. Yeah.
Can you explain like the lattice method?
Sure. So like 13, since it's right here, this might help explain the correct way to do it. What mistake? Did anybody identify the mistake this person did? Did you do what? No?
They come by boxes, not by.
How are you supposed to add this?
No,
diagonally, right? So 1, 6, 5. So what you said is correct in a way. They didn't end up carrying the 1, but they didn't end up carrying the 1 because they didn't apply the lattice thing correctly. The lattice addition is before a student even understands carrying the 1. And if you do enough of these with them, you'll go, do you see how you keep doing this? Hey, let's just make that a rule and make it quicker so we don't have to keep drawing these boxes, right? Maybe? Do you guys agree lattice method is actually kind of cool?
Yes.
Do you also understand that you don't want to have to do that forever? It's much easier to add like 4 things together just doing it the standard way than a bunch of boxes. Isn't that crazy? Does that answer the other question well enough? I mean, that's all there is to it, right? So, how did they get a 1 and a 1 here? They did that right. All the stuff in the boxes is right, yes? Where did the 1 and the 1 come from? 4 plus 7 is 11. 7 and 8 is 15. 2 and 2 is 4. Yes? That is very simple for a student at the beginning stages, before they even know how to carry a 1. That is really simple to follow. They know what 4 and 7 is. They know what 7 and 8 is. They just don't know to carry yet. Maybe? And then diagonally, they know how to add those. Okay. Yes? Oh! I mean, okay. 19 is 1 plus 18, yes? You with me? Yeah, prepare yourselves. I'm about to tell you something groundbreaking. 19 is 1 plus 18. Is that an example of what I want? Because 1 is not composite. Is it prime? Is 1 prime? No.
Unit.
That's a unit. Because you can't express it as itself times 1, because it is 1. I know you didn't make it 1 times 1. So 1 plus 18 doesn't work. Keep going. 4 plus, are those composite? 4 plus 15, those are composite. Do you see what I mean? So this is an example of making the list. So you make a list for all the ways to add to 19. There's one other way to get this to work. 9 and 10. There you go. 9 and 10 is the other way to make it work. Right? Oh, man. No, I want that just as a little vignette moment. 9 plus 10 is 19. Sick. Oh, man.
Can we go over 8?
Sure. Oh, okay. I mean, just what does that mean? What does the 5 mean? What do I have 5 of? Yeah, so the most direct way to do this is 3b times 3b times 3b times 3b, because literally I have 5 of whatevers. You could then break it down into 3 times 3, that would be what you would do next. And real quick, you guys, alright, guys, does everybody know this would become 3 to the 5th b to the 5th? Very quickly, because this is way too cool not to talk about. Well, shit, Jeff, you have no paper. Oh yeah, you do. There it is. What were we going to talk about? Oh yeah, that's right. What can I do with this? Distribute, correct? Why does that work? Because this is based on addition and this is addition. Yes? Something based on addition should play well with addition. Do you guys agree? So that is why this is not easy. This is not easy. There's a lot of work that goes into this. Do you guys see why? You can't just do 4 cubed plus x to the cubed, because what is the 3, what's the exponent based on? What's the exponent based on? Multiplication, not addition, so that's not going to play well. Does anyone know how to do that? How do you cube anything? You write it. If I said do 18 cubed by hand, what would you start doing? walking out the room, Jeff. I don't blame you, but just pretend. What would you do? You would write 18 times 18, and then you would do times 18. You would write 18 3 times and do it. So what do you have to do? 4 plus x times 4 plus x times 4 plus x. Foil, 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 foil. Go crazy, go crazy. End up in the middle of the room, staring at the ceiling. You guys with me? I need you to be really with me. This is easy as shit because coefficients are based on addition. This is hard because exponents are not based on addition. So therefore, what if exponents are based on multiplication, and I put in here something that is multiplication, should it be easy? Yes. So this is distribution, yes? Distribution. This is also frickin' distribution. The same exact reason, the same exact way. So I'm going to cube 4 and I'm going to cube x. Yes? Now, real quick, do you understand this is a higher level thought than just, so that's too high of a level. 5th power means I have 5 of the base. That's what it means, yes? Did I count right? I did, yeah. That's what it means. And then you could go, oh, we can gather our 3's, and that would be the next thing you could do. And then you can get to the shortcut. Oh, you can distribute the 5 because you end up with 5 3's and 5 b's. You guys see that? That's the progression you would take. But that's the immediate way to rewrite that and expand it. No, that's expanded form.
Okay.
You don't have to go any further. If you went further, I'm not going to take points off. That would be really evil. You did it right. Screw you.
So then that's why the 3 to the 5th power and b to the 5th power is wrong. Because it's not in expanded form.
Yeah, that's actually written in simplified form.
Yeah.
That's expanded form.
Okay.
Yeah. Yes. Those are the 2 I can't do. No, 10. Compatible numbers. What does that mean? Happy together. How is the weather? Bum, bum, bum. Thanks. Now it's in my head. So numbers that do what together? Besides just be happy. They make a nice whole number, right? So 4 and 6 are compatible. Simpatico. So what 2 numbers in there are compatible? So 62 and 38. Right? Because what do they make? 100. They make 100. So you could use commutativity, associativity to get those together. Yes? Huh? Yeah. So you would move, if you want to do it officially, you could move the 81 and the 62. I can't remember how I did it on my, and then you would move the parentheses over, yes? I think I did it a different way, but we'll see. And then 62 and 38. So 100 plus 81 is 181, easy as shit. So if I have a long ass string of numbers that together, I look for my compatible numbers first, right? If you have a long ass list of single digit numbers, you look for 4 and 6, 3 and 7, 5 and 5. Yes, of course, we kind of do this naturally, but this is just, one level up from that. 11, what does compensation mean? What's it mean? Oh yeah, one number gives something to the other number, right? So what number could 5 become that we love in terms of multiplication? What number could 5 become that is awesome to multiply by? 10. What factor does it need? Does 212 have a factor of 2? All right. So you take a factor of 2 from the 212 and you give it to the 5. Why is that legal? Because what is 212? 212 is 2 times what? $212 is what times 2? 106. And then what's 2 times 5? 10. And then you just throw a 0 at the end, right? So that's compensation. So if I see a 25 times 44, I'm going to take a factor of 4, make 25 100, right? You look for the numbers that could become really nice numbers, 10, 100, even nice numbers to multiply. Does that make any sense? Additive compensation would be if, so like an example of additive compensation would be 33 plus 19. This is 32 plus 1 plus 19. 32 plus 20 is 52. You guys see that? That's additive compensation. I take one from one of them and then give it to the other one. You guys see that? I could have taken 7 from the 19 and given it to the 33. That would have been 40 plus 12, which is still 52. So compensation can go either way. Whatever way makes more sense. And I normally, if it's one away, I'm going to take one from the other dude. Yeah? That's compensation. Compensation is operation independent. It's just one thing gives something to the other thing. If I'm doing multiplication, it's got to be a factor. If I'm doing addition, I got to subtract from one and give it to the other.
So why would you take, 207 times 10 all of them?
Because 107 times 2 is 214. I have 212, correct?
Yeah.
If I take a factor of 2 out of that, I get 106. 2 goes into 2 once, 2 goes into 1206. Where do you think the 107 is coming from?
I think I just understood it wrong, because I thought we were just.
Oh, no. Since the operation is multiplication, we have to use division to move stuff around. I could divide 1 by 2 and then give that extra factor 2 to the other guy. Just like with additive compensation, I could subtract 1 and give it to the other guy. So whatever I do has to work with whatever operation is there. If I see multiplication, I gotta use the division. I gotta use a factor. If I see addition, I've gotta use subtraction. Take something from one and give it to the other. Does that make sense?
Yeah.
Okay. Oh. What's equal additions, guys?
What's when the amount you're adding is the same?
But so, right? It's when the amount you're adding is the same. So what is it about subtraction? It tells you the distance. So if I make one go up by 2, I have to make the other number go up by 2. Equal additions. So 231 minus 28, make the 28 go up by 2. Isn't that a much better number?
Oh.
So then I have to make the other one also go up by 2. Please tell me this makes sense. Subtraction is the distance. If I make one number get too closer, I gotta make the other number go too further away. I gotta equally add to both, and the distance is the same. So the answer to the subtraction is the same. Subtraction don't give a shit what the numbers are. It just wants to know how far apart they are. So if I make them go, now the same distance apart. Yeah.
Do you think, 9?
I should just give the key.
I know.
Yeah, 9, there's a lot of misunderstanding about this in the homework. The range for the estimate, I should just say range estimate, but you literally just make it, the low estimate would be 800 times 500. The low estimate. The high estimate would be 900 times 600. Now we talked about improving by taking the average of the two we get, but that's how you get a range. Yes? So do you understand how long it would take to set that up and actually multiply that out by hand? You with me? If you had 869 times 578, 9 times 8 is 237, right? That would take a while, correct? The range estimate is quick as shit. If you do the range estimate, you can compare it to your answer you got from multiplying it out and see if it makes sense. If I multiply it out, my answer is 600, and the range estimate is 50,000 to 90,000. I'm freaking wrong, right? Let me go back and see what I did. Yeah, maybe, maybe, no, screenshot. So let me do this. Let me go ahead and give you guys the key. I'm I'm like, I already did all these problems. All right. Oh yeah. Remind me when I get back to my desk. Oh, sorry. You're welcome. So you can have this because, you know, I know you guys can't get enough of my handwriting. Now, real quick, just to remind you guys. Who wanted a blank? Do I have a blank copy? I've been writing on these. Yes. Guys, if you did not try the practice test out, do not look at the key. Don't look at it. Don't. Because you'll end up building false confidence, right? Yeah. I would have done that. And then you feel like you know, and you don't. Okay. Some of you guys are not going to listen to me. You're going to look at it, and you're going to feel like you know it, and then you're but there's only so much I can do. I understand if you don't have time to do the practice test. The practice test is just extra. You don't have to do it at all. Do the homework. Yeah.
Go over number 2.
Yes, of course.
Oh yeah. All right. So this is another example of making a list. So I know I have whole number dimensions. Do you all agree with me that there are decimal numbers that multiply to be 72? You with me? So I'm saying for somehow my garden has whole number dimensions. And I know it has an area of 72 square feet. Can somebody give me one set of dimensions that would lead to that? 9 times 8? Yes? Okay. 9 times 8. What would that mean it would look like? 9 by 8, Jeff. But isn't that 8, 9? So how big of a perimeter does it have? How much fence would I need then? Add those up. 2 8s is 16, 2 9s is 18, 16 plus 18 is 34. I want to make sure you guys understand the physical idea of the problem. Do you all agree with me that a 9 by 8 garden would be an area of 72 square feet? How much fence does it need then? 9 feet plus 8 feet plus 9 feet plus 8 feet. So I need 2 8, 16 plus 2 9s is 18, 16 plus 18 is 34 feet. Is that the only dimensions that would make this work? No. So if I were you, this is all about making a list. What's kind of like the dumbest way to set this up that would still be 72? 1 by 72, yes? So you have this long ass garden. So you open the thing, you're like, all right, let me paint it. Right? Okay. Very strange way to do things. Can you figure out, now real quick, do you guys see, do you see how, if it's 9 times 8, I'm going to double 9, double 8, add them, yes? Aren't I going to do that every damn time? So if it's 1 by 72, double 1, double 72, add them, that's how much fence you need. Keep going. Bum, 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 bum. There are 6 total situations. And you see them all in the answer key, but don't look at it. Try it out yourself. So when you're making a list, you want to be systematic. Systematic, automatic. So you want to do 172, 236, 324, right? You want to kind of be, so you don't miss anybody. Okay. Is that? I told you 6. There's 6. 1, 2, 3, 4, 6, 8.
So for a question like this, we have to write out like all the possible answers.
Yes, make a list. I'm going to make a special problem just for Grace's test. It's going to be 5 pieces of paper. Good luck, Grace. The whole thing there is there's a lot of restrictions. It's gotta be a whole number of dimensions. You can list every situation, and there's only 6. And then in each situation, how much fence would you need? Right? The least amount of fence is the 9 times 8 one. The closer it is to a square, the less perimeter you need for the same area. 1 by 72, you would need double 1 plus double 72. You would need 146 feet of fencing. 9 by 8, 34. Same area, yes? Okay.
You're gonna use a calculator on this test?
Yes. Juju. Juju. Okay. By the way, I will have one problem where you will have to come up and use some of the manipulatives. I'm gonna watch it. It's gonna be so exciting for you. Will you? You'll get a chance to practice, and then you'll call me over and you're ready, and you'll show it to me, right? You with me? Is that okay? The funny thing is, even if you say no, I'm still gonna do it. I should say, is that understood?
Understood.
Okay.
So this says covers until
5-1.
till 5.
So it's 1-2, chapter 3, chapter 4, 5-1. Remember, like chapter 4 has 2 sections in it, chapter 3 has 3 sections in it, so it sounds like it's chapter 3 and chapter 4. Has anybody recently gone to the Mass Science Center for the first time? Anybody? Some of you guys are going there for help, right? I see some of you guys in there. And like I said, they basically have a tutor that can help. Be a little careful when you go in. Not every tutor feels comfortable with 125. You with me? So if a tutor comes over and they start, and they're like, wait, and then, can you find out who's on duty that knows 125? You with me? But they do have at least one person on the entire day, except for 30 minutes on Wednesday evening, I think, if I remember correctly. It's almost all the time. And then if you're in there, like, nobody can help you because they're out sick, then my office is like, I know I'm not in there all the time, but sometimes I'm in there. You guys know? And I don't mind. You guys know I'm in that room that's right next to the Mass Science Center. I'm in the Sissel, and I think I'll put that up on the office hours. If you have a question and you wanna come in there, I'm fine with that. Come in there. When I'm in there, you can go in there. It's supposed to be for calculus students, but if you're my student, you come in there, I'm gonna help you. Stare at that chair. By the way, if you are ready for the test, you don't have to stay. If you're ready for this test, right? Sometimes I get people, and then people are like, I don't wanna leave it in case somebody asks you a question. And then we end up looking at each other for 15 minutes. So is there anything you wanna focus on, something we haven't talked about yet? It's pretty cool with number 3, for example. What if I gave you a multiplication table? Like a base 6 multiplication table.
Are you saying you're going to?
I could. Yes. Do another one like this? Oh, sure. Okay, real quick, let's do this. Let's do a speed round of concrete examples. Yeah? Speed round of concrete examples. 7 into 52. Help me out. Help me out.
Oh, me?
Yes, anybody.
Sorry.
7?
49.
7 times 7 is 49. Now interpret your results. 52 is 7 times 7 plus 3. You with me? So watch this. What if I get, I'm going to go even further than A. You ready? I'm going to, B goes into A. No, Jeff, don't use R. Use M, R, D. Yes! You asshole, Jeff. So what is A then? A is equal to what? A is almost equal to B times M, but it's off by D, right? So A is equal to B times M plus D. That's what that means. That's what it always means.
Right.
The remainder is how much the number inside was too big for the number outside to go in evenly. And the problem I gave you on the test, weirdly enough, is harder than that because it's a mixture of numbers and letters, which sometimes is just harder to look at. Does it make any sense what I just wrote up there? Or are you guys like?
That part makes sense, but when you have the numbers for actual form, I don't know why you subtracted.
Oh, so what if I want to know what BM equals?
Right.
What would I do to get this by itself? Subtract D. So BM would be A minus D. That's all. So if I know 25 times B, I forget what the number was, plus something equal, yeah, I subtract to get what 25 times B is, right? Yeah.
For the first and second method, if it's 7 and 52, you're just doing like an estimate.
Oh, you're,
Like 7 times 7.
you know, like what number below 52 does 7 go into? 49, and that's 7 times 7. Because the whole idea is, you don't want to put a number that takes you over the number you're looking at, because that can't work. So you always think, what number below this does that number go into? 49. Okay, that's 7 times 7. Now if I subtract, I can see how much is left over, right? So you're always kind of like taking it down to the next number that that outside number works with, that the outside number goes into. Yeah.
Number 3, you got 5. You got 5 base 7 for number 3B. You got 5 base 7, but you need 6 base 7.
Huh? Let me see. Here?
Oh, never mind. I just marked it.
Oh, okay. Yeah, part B, that's a question I'm asking. I didn't get, all right, I don't know if you're talking about the work I did.
No, yeah, I just did only this 3.
Does everybody understand that 3B, number 1, you don't have to do any work. You just look at the work you did. You find 12, right? So I try to show the way I did it, but that might not be easy on the backside. So like, I found 12 that goes with 4. So 12 equals 4 plus what? 5. So you see how I'm using missing add-in? Because I have an addition table. 12 is 4 plus 5. So what's 12 base 7 minus 4 base 7? 5 base 7. I always want somebody to walk by when I'm up here saying 12 minus 4 is 5. Somebody's walking by like, what are they teaching people? So you don't have to do the base 7 work. You see that? That's not my point. My point is, can you use what you just did with the table Missing added is really what you're doing there, yeah. What does 4 need to become 12? That's how to interpret 12 based on the minus 4. And you can look and say, oh, what does 4 need to become 12? Well, it needs a 5. Maybe if you guys can. So what would 14 base 7 minus 6 base 7 be? 14 base 7 minus 6 base 7. What does 6 need to become 14? 5. See it? See it? 14 base 7 minus 6 base 7 must be 5 base 7 because 6 base 7 plus 5 base 7 is 14. She gets. She likes the food. I'm done with this. Wouldn't flip tables if they weren't so flippable. Alright. And of course, part 2 is the same as part 1, just 2 problems for the price of 1 there. So it's really interesting. The last thing in the world I want to do is to be like a roadblock for somebody trying to get to what they want to do with their life. At the same time, you have to understand everything we're doing is really important. And I really, if you do become a teacher, I just hope you can be that teacher that inspires students to do math. Not the kind of teacher that unintentionally lets your students know, oh, math kind of sucks. Oh, math is hard. You know, you see what I'm saying? You're not even necessarily saying math sucks. Just, you gotta be careful about the way you work with it and talk about it. You're gonna send off these signals. Some of you guys have lived through that maybe. And I've had math teachers that obviously did not like their job. I'm like, I'm really happy I like math coming into this course because you would not help me, right? You guys ever had like a history teacher that seemed to hate history? Or like, you know what I mean? Like, why are you doing this? Stop doing this. I feel bad, but I mean, give me a few more years, maybe I'll be like that. People don't believe I brought nothing. I had nothing. Yeah.
On number 15 where it says tree of time factor tree, when you get to 9, why wouldn't you
Oh,
write the 9?
Should be 3 times 3, yeah. Yeah, so you can make this 5 squared times 3 squared times 23. I have no idea why I didn't break 9 down. So guys, on number 15, I made a mistake. That 9, you can go, of course, 3 times 3. I think I got to 23. And I always make the joke, have you guys heard about the movie, The Number 23? No. Jim Carrey goes crazy because he sees 23 everywhere. So I kind of was like, oh, 23. I didn't ask on number 15 for you to write it like this, so you don't have to. The tree, you can stop at the tree, but you should go one more level, of course, break that down into 3 times 3. Every math teacher just loves making mistakes like that. You know, I want to say one more thing about these. One of your students, like the problem where I say one of your students says this, always answer that as if you're talking to them. You see what I mean? When I say, what would you say to the student? Don't say, that student was wrong. They really, you know, no, you're not going to, oh, okay, let me see. Oh, you're so wrong. You were wrong. Were you here? So pretend like you're talking to them. I want to see how you would say and what you would say. Right? Don't talk to me. Because you know I know it. You're not going to talk to me the way, you're not going to say everything that I need to see. If you're thinking about me. It's not me. It's your student. You need help. So just to let you know, the kind of problem I might give for the manipulative problem would be the base 10 pieces. And you have to do it that would lead to borrowing or something, right? Like, I'll tell you, to subtract, you have to take a base, like a flat and make it into 10 longs, that kind of thing, remember that? Nothing too crazy, something we did before.
Okay, wait, is 5.1 just factor in the rules of each number divided?
Yeah, 5.1 had the divisibility rules, but it started with, some other topics. I can't remember what the first. Oh, yeah, primes and composites, yeah. I forgot where those were. Yeah. So guys, real quick, if I asked you, like on a test or something, if I said, is 117 prime? And I said, without using a calculator, tell me if 117 is prime. Can anyone see, what does prime mean again? Divisible only by 1 in itself, so 117. 117. What's 1 plus 1 plus 7? 9. What does that mean? It's divisible by 9. It's divisible by 3. Do you see what I mean? So that kind of question is 117 prime. Prime means divisible by only 1 in itself. Oh, let me check. Is it divisible by 1 in it? Then I got divisibility rules. You see what I mean? So a lot of problems, you have to stop and think, okay, prime means this, how do I check for that? Oh, I can check it with, you see what I mean? You have to kind of like go down that progression. I don't give you like a ton of problems that are multi-level problems, but that's another, like there was one on here, like number 5. It's a very straight, just simple, tiny little question, and then you're like, oh, it's got a couple levels to it, right? You guys with me? I'm really hoping some of you guys start to realize those divisibility rules are really useful in a lot of little places. Not like every day. I always love it when a student's like, how's this gonna help me find with this? I'm like, I don't know, man. You do a better job, the more math you know, and then you can afford more lettuce. I had somebody do that once. They basically asked, how is this gonna help me do this thing? I'm like, why should it? What do you mean? Sorry. So be ready for those kind of questions. Especially if you get some older kids. You're gonna get a lot of, why do I care about this shit? You know, little kids are gonna,
Why do I care about this shit? Straws. Why do I care about this?
no, you're not gonna get a lot of that, I don't think. I don't know.
What the hell's wrong with you teachers?
Probably not gonna get a lot of that. And if you do get some of that, you go, what kind of home life do you have? So are we questioned out? Does anyone have any other questions? Because I don't want us to have to get progressively bigger stories I want to tell you. Does anyone watch Only Murders in the Building? You ever heard of that show, Only Murders in the Building? It's got Selena Gomez in it. See, it's on Hulu, yeah. It's got Steve Martin, Martin Short, two really old guys, so of course I like them. Hey, sorry.
Okay.
I don't know.
Oh, we could too.
Hmm?
That's because Selena Gomez got married.
Oh, she did? Yay. No, that's good. She's a good person. She seems to be a good person. So. See, what did we not talk about? Let's see. We talked about everything here, didn't we? Yeah. Yeah, we talked about every single one of these. Yep. Okay. Do we have decorations up for Halloween?
No, I'm ready for Christmas.
Oh, you wanted to-
That's all she talks about is Christmas.
When do your Christmas decorations go up?
I don't know, it depends. If I'm
Is it
at
after
home-
Thanksgiving or
It's
before
after.
Thanksgiving?
If it's,
Bad and cool.
if I'm at home, then after Thanksgiving, but if I'm here, then whenever I want.
I see. I like to, like during the pandemic, over summer, I was putting Christmas decorations up. So, live and
Right.
food. I'm somebody, they come down by January first at the latest with decorations.
I have neighbors who have it.
I want Christmas to be special, and I want it to live in its own thing, right? When they go into Rite Aid or like if something, and they have Christmas stuff in October,
Oh, and then
screw
it
that.